Lesson 3. We are studying today which brand of cookie has more chips and how many more chips. We're going to discover this through a 2-sample t-interval for means. And we're going to do a state plan, do, conclude, which with the confidence interval uses the acronym PANIC. And we'll discuss what that means here momentarily. Okay, what we did in class was I had Chips Ahoy and then I had an off-brand Chips Ahoy. And what we did is I gave everybody in the class a cookie of Chips Ahoy, and then everybody also received an off-brand cookie. We tore the cookie apart and we counted how many chips the Chips Ahoy had, and we tore the other brand apart, the off-brand apart, and we counted how many chips the off-brand one had. So I'm going to go ahead and show you how that we did this in our calculator. So the first thing I did was I opened up a spreadsheet, named it on brand and off brand. And then I did menu 411, menu, stat, calc, one variable statistics. And we have 2 lists. We have on brand and off brand, so I did 2 lists. And I have my X list is on brand. And my X2 list is off brand. And then I just hit OK. And you can see that I got 21.76 for my mean for the on brand, 18 for the off brand. I got 3.19 for the standard deviation for my on brand. And I got 2.41 on my off brand standard deviation. And I have N is equal to 13. That means I have 13 of my off brand, and I have 13 of my on brand. So those are the only 3 numbers that I need from here. I'm also going to show you another trick here in a moment once we have done this as far as from here. So let me just review again what I did. And I'm going to show you here is that I did, excuse me. And so then what I did here was I have, to be able to get this, first of all, I entered my data, and to do that, I opened up a spreadsheet, and I labeled the spreadsheet, and I made sure both one had a label here and a label here, which you saw from here, right at the top, on brand, off brand, didn't matter what you labeled it, needs a label though. And then I did menu, four, which is stat, 1, 1, and I have 2 lists because I had this list and I had this list. And I was looking for a couple things. I was looking for the X bar one, and then I was also looking for my S, which I found in a second, which I'll show you in a second. And then I'll look in here, S2. And then I was looking for N1 and N2. Okay, so I'm going to do this is called state plan do. So the first step is to do the P, the parameter. And again, I showed you before you could put mu1 is equal to the mean number of chocolate chips in Chips Ahoy. So mean number of Chips Ahoy chips. And then you could say mean 2 is equal to mean number of off-brand chips. Or you could do it like this. True difference of mean, and it says Chips Ahoy minus generic. The confidence level is 95% because it gave it to me, and it said 95%, create a 95% confidence level. I apologize, I guess it didn't, that's my default level, but if it usually does give it to you, and if it doesn't, we use 95%. Okay, my assumptions and conditions, we have to check my assumptions, which is random and normal large. And I see, remember, that means I'm looking for N1 bigger than 30 and N2 both bigger than 30, but you see mine aren't. However, it does say assume that they are normal. It says right here. And the samples are random. So my large sample size, the whole idea, if a sample's large, then it's normal. So if I already tell you it's normal, I don't need it to be large. Large means when N is greater than 30, it guarantees me that it's normal. When N is less than 30, I'm not guaranteed it's normal, so I have to look and see if it's normal. But if it already told me it was, I don't have to look. Okay, so now I'm going to do, I'm going to do menu, stat, confidence intervals, and I'm going to do a 2 sample t interval. Okay, and we're going to put all the data in, those numbers that I told you that we needed, which is right here, which I'm going to show you. These are the ones that we're going to put in. I'm going to put this in for X1, and you're going to put this in for S1, and you're going to put N. And then for this one, X2, S2, and then N2, and then it's going to be 95%. It's going to ask the confidence level, you're going to put 95%. So I'm going to go ahead and put these in. So let me go ahead and get a calculator page open. So just open up any calculator page. So I'm going to open up a calculator page, and I go menu, stat, confidence interval, and this is a two sample t interval. And we're going to put in, you could put in data using the data we already, found, or you can put in stats. And we have X1, as I told you, I just said, 21.77. S1 is 3.19. N1 is 13. And remember, this just comes from what I just circled. S2 is 18, or excuse me, X bar is 18. The next one's 2.42, and N2 is also 13, 95%. It's not pooled, and okay. And there's your confidence interval. You can see it here. I'm going to just screenshot this and show you here so I can highlight my confidence level. That's my low, 1.49 to 6.07. And what that means is I have between 1.49 and 6.07 more chips in Chips Ahoy than in the other brand, because they're both positive. And because they're both bigger than zero, both numbers are bigger than zero, I'm saying, yes, that is statistically significant, because zero is not contained in the interval, and that means they're always, in my interval, greater than zero, which means more than the other one. Okay? So let's go ahead and draw your conclusions here. So you can see I went ahead, what I just said was exactly what's written here. And that's my answer and my conclusion, exactly, it's stated out here, exactly what I just said. And this is because, yes, it's greater than zero, that both of the intervals are greater than zero. Okay. And I'm checking random, I'm checking normal. Again, remember, if it tells me that it's normal, I don't have to check large, because that's the whole idea. Large guarantees normal, but if it says it's normal, I don't need to check the large. All right, and then here, the same idea. You're going to do the same thing here with this. You'll put the data in, and you'll come up with the same state plan due. And here you can see the answers that are through. This one I know is not right. This is the actual interval. For some reason, it's the wrong numbers. But it's, again, the same idea. You're going to do the exact same thing. I'm going to show you one more trick. When you do, since we already have data in here, I'm going to just show you one more trick. Since we already had data in here already, oh, not in this one, but we had it labeled, I think it was this one. Yes, on brand, off brand. You can also do menu, stats, interval, and then two sample t interval. And when it says data or statistics, you can do data, and all you have to do is put your list 1 was on brand, and list 2 is off brand. So you can do that. And that's all you would have to do. And you would hit OK, and you can see you're going to get the same interval, that 1.46 to 6.06. So you can do that for this one if you want. Put your data for Chicago in, your data for New York in, and do the same thing that I just did. Is there evidence, the mean monthly rents in Sioux City? And yes, because look, again, they're higher. They're lower, because it says negative 172.02. to negative 914. So what that means is it's this much lower to live in Chicago on average per month than New York. All right, I hope that helped. And if you need any other questions, let me know.